So let's ready to go again. So I don't know if the wireless robot is still on your desktop, the folder, or that's gone. Yeah, you need to bring it up. So from the common network drive, oops, wrong class. So where's a wireless robot and a TSK file? Yeah, mine is still here, but let's see. Let me try to override it so that it's the same. Okay. So inside a wireless robot, go to code, app, and the binary is the cmdatalogger.tsk. That's the one we should have on it. It's not the wireless cowbot we've been using before, where you kind of remote control from a PC. This is a different one. This one, the one designed to work with this. So double click on it and download on your bot. So right now your bot should have, last time you work on it, you already have them through network, manager. So you have them all synchronized between the two already, and I kept them there so they're paired, so we don't have to do that. So that just makes sure we download this one. It's gonna be on COM1 because it's using wire. Okay. So while we're here, we can look at it and see what it's supposed to do. So a program runs as an endless loop. If something arrive, the new data arrive, if we're gonna arrive true, we're gonna actually it's saved into WRX data. That's all. Okay. And then if there's that is nothing, and then right now a bunch of if LL doesn't do anything in here. Okay. So you can when you expand this one later, let's say for the you want to work on the PC, the mobile sensor network, where you send out several of these cowbot out. It's up to you what to do here. But right now it doesn't do anything. So if because we're not gonna ask it to be moving to do anything. So nothing do anything. If up data was sent from the PC side, and we'll know what that up means. And then if 2 down has been pressed left, these are WASD on the PC side. Okay. Or if somebody sent out a number 1, A, 2, 3, that's line before. Or 5, do something 6. So we're trying to simulate all the button on your the RC100. Okay. Else, and this one is just when you send in, we're gonna have a piece of code that send in special numbers. That's all. Okay. So basically, the bunch of just simulate the RC100 remote controller, and then if you're sending different things, which we more general purpose message.
Where's that?
And then wireless, code, app, binaries. And also, I compiled with the version 2012 here also. Hopefully it will work too. At least I checked it worked last time. We'll see. This computer being revised all the time. Sometimes I don't know. Oh, no, that one I mean. Okay. So essentially just buzz a little bit. That's it. Okay. If it receives something, it buzz. Okay. And then that's a big if remote code arrived true. That means if it received a valid packet. Else, that if it did not, this part here, is what it is whatever it's TXD it's sent. I mean, we're gonna be able to use the up, down, left, right button on the carbot to send something back in this application. Okay. So WTX data, well, it's just old data. So first it's initialized probably 0. So oh, here we go. It just cleared it out. This one, the old data is saved. And then to know what's going on, if you press the up button, whatever the up button is, which is not the same thing as the up button on the RC100. Okay, remember up button on RC100 was number 1. Actually, the number 1. So up button on the CM5 is different. So if you have different controller, they may map it to a different number or even. So it just depends on the bot. But it's just so that we know. So basically, whatever. So we add one. Well, the up button. Oh, this one. No. If the button on the CM5 is push, and then we take whatever the button of the RC100, which is really 1. So essentially, I'm adding 1 to WTX data and send it over. 2, send it over. 3, send it over. I mean, that's just to mimic back the thing. Okay. If the transmitting data is bigger than 0, that means you are pushing, yeah, and then send the TXD data. Just send the TXD data. If TX data and 0 and data is positive, no button but press, but well, through the last time send a packet. Okay? Just a plain blank packet. TXD, remember, wherever TXD is sending the ZigBee packet, it doesn't send like print line or print. Remember that lecture when we talk about the difference? When you send out the packet, if you read at it from the output the window, it has like UU and then have funny character instead of just a data. Okay, so remember, every time I TXD here, it's sending out in the packet. And remember what? When you remote clone RxD, the firmware actually receives that 6-byte packet, but it stripped out only the data and saved to WRX data. Remember that? Okay. So the bot, its own firmware, is taking care of ripping that out for us. When you send it out from the bot and the PC receive it, we're going to show some code how you can unpack it and take out the thing that you need. Okay. So it's on it. So unplug it and run it and just let it be there for a moment. Okay. I don't know if you noticed, but when you start running it, this LED will blink and then it becomes solid. That means you have solid between the two bots are talking to each other now. Is it solid? Okay. So it's solid on the little LED. Yeah. I mean, so they are connecting 1 to 1 now. Hopefully to the right one, I think. And anyway, so that's done. So let's minimize this. On that same daddy logger, right now we're just gonna run the play little game here. That's all, okay? And we need to know what is the COM port on this one. On the USD data mixer and all of that. So let me do a quick one. I just go to manager to find it. Where are you? There we go. So whatever this thing is for you, it's not COM1. For me, COM3. Hopefully it's still COM3 on your side. Okay, so mine is to COM3. So go to that binary on the wireless robot. board, COM3. So find the PC dialog that we see. This one, see, oh, good. Finally, it's working properly. It's just a MS-DOS window. So this one is talking through the USB Dynamics of ZigBee serial here. So it's ZigBee wireless. So that's COM3. So when it come up COM like this for you guys, right? So we want COM3. So put 3. And it will respond to COM3. If there's something wrong, it will email. It will give you error messages. So we look into the detail of the code soon. You can output to a file. So say put on Y, and just enter the file name. So for example, test1.txt. It's just an ASCII file. So hit that. It's a file open successfully, and then you look in the folder where you play with it. Hopefully, when you put it on the desktop, you see that a new file called test1.txt or whatever you use. It's right now it doesn't have anything in it. And then we could improve the menu a little bit better here, but essentially just plain to quit to press. But if you do WASD, so they put W now, I push W. It's transmitted 1, correspond to up, ASD, okay? And then keyboard 1. So the keyboard actually number 16, yeah, button 1, 2, 3, 4, 5, 6, 7. I put 7 is no. So if I put anything else, if you put anything else on the keyboard, right now basically the keys of code on the PC didn't accept that. So it's like, nothing. I'm just thinking junk, and then it won't send anything anymore. So if you go WASD again, so basically in this mode here, if you push WASD 1, 2, 3, 4, 5, 6, it will send it over. Okay, and also you notice is anytime you push one of the valid key, for example B3 here, it's flashing as being received. Okay, and then as soon as I push any kind of weird key here, it stops communication. They're not sending over. Okay.
When I press up, it like hears out.
Hmm.
When I press up.
What do you mean up? WASD.
Yeah, that's what. Well, before it just aired. It's not
It-
coded anymore. It just aired itself.
So maybe you have handshaking problem in the first time. Okay. So that's what it does. Okay. Now let's say if you want to push on the right now it's two-way communication. So let me push the up button here on the bot itself. Okay. It shows, oh, I receive it, but then she sees it a lot. Why? Because my finger, no matter what, is not that fast. So it is sending over quite a bit. Let me push real fast. So even I'm hovering around a lot. Every time I push in, there are a bunch of them over. Okay. Because my finger is just not that fast. Left, right, down. Okay. And also you can see that also very careful here. Inside the code, we simulate to this one here. If no button not pressed but will last time through the loop, then send an empty packet. Okay. This section in here is to simulate the remote controller with real remote controller. Remember, it's whenever you release the button, it sends out actually a 0 over. So you can use that to detect when it does. So basically, you see, because it sent over quite a bit of message. So whenever you design this one and you are interfacing with a button on here, people are just going to be so slow. Like you probably had to create a routine where you keep on reading what is the new data with the old data, and only until you read 0, you say, oh, that guy finally finished pushing the button, and then you whatever the old data is, that represent the input. Okay, because there's a bunch of them coming in, and no matter how fast you push, humans are slow. There's communication. So whenever you write a program, you have to adjust for that, and that's very tricky. Okay, you can see that you have to insert an array or a buffer, and all the data coming in all the time, and you keep on watching it until you reach 0, and you say, oh, communication had been stopped, and then now actually you look back and say, oh, the message was blah blah blah. So that's the thing is when you do on communication, you have always to wait until because the stream coming at you all the time. Some way in the stream there must be something that tell you I'm done. Okay, like you gotta do walkie-talkie or CB radio. You keep on talking and saying there's a signal when it's over, right? What was that one? Huh? 10-4?
Well, that's just where like
Yeah, 10-4 finish, and then you can do so you know because there are so many things. Same thing. So over, yeah, over is the thing, and then you can the other guy talk or something. Because remember we are what half duplex. Actually, well, running full duplex now. I mean, it can run either way right now, both sides. But yeah, so we need the right set code to handle it. All right. So that's what how the button receiving from the robot side. So if you push T, we made special that if you push the button T, and then you can send in your special message. So you can see that later for application, you may want something like T to send something, scan S to scan where you send the command to a specific one, say, oh, scan the infrared data and tell me what's sending back. Okay, this is just a Scotland thing. So T is to say, oh, you want a 16-bit message, and you can enter as decimal, like 1, 2, 3, 4. That's a decimal. Okay, so anytime it beep like that, it's sending over a beep to let you know. It's saying, oh, decimal transmitted a custom message. And then you push T again, and you can think that as a hex. A hex is always start with a 0 and a small x, and then A, B, C, D, for example. Because remember, hexadecimal is what? Symbol using 0 through 9 plus A, B, C, D, E, F. So 0x A, B, C, D is a perfect legitimate hex number, and you hit it. So it's sent over A, B, C, D. The decimal equivalent to it 43,981 essentially. Okay. And if you want to send in binary, you have to push T again. You have to preface with a B. Why? Because the computer will scan all these things as a string. So when we see the code is when it scans the first character. A string is just an array of character. So read the character and know what's going on, what to expect next. Okay? Because when it reads this thing here, and this is important, when it reads anything that you send out on the keyboard is a character, like a character for the number 0, a character for number 1, not the actual number itself. Okay, I don't know how much of MATLAB programming you guys remember or did ever that covered, but there's a string and there's a number, right? A parameter can be a string, which means they have character, which is the letters, and then the number. So 0 can be a character 0 or number 0. There is a big difference on the PC side. Okay, so when you're typing through the keyboard here, I'm actually enter character B, 0, character 0, character 1, character 0, character 1. So with the software, and we'll see the detail later. Now today, probably next Thursday too, to finish this up, probably, because you guys don't know C. But what it does is read that, and then it transform the character. So when it send out a little packet over to the bot, it actually send the numbers 0, 1, 0, 1. Okay, so that just send it. So binary 0 to 1 happened to decimal 5, equivalent to that, and so on. Okay, and then basically that kind of the demo of how it's working. Any question here? Okay, so basically this piece of software kind of present, obviously there's some code on the CM5 itself too to send things back, but on the PC side, on the CM5, it's just classical, remote control array, RxD, remote control RxD, remote control TXD, you already know that. So yeah, on this side, we're going to show more detail.
So the program, I guess,
which
the background changes it to the ZigBee
it
code.
prepare the ZigBee packet properly and send it over. It also, when the ZigBee packet received from the robot, it unpacked it properly and presented to you.
So, like, I guess when we put the hex, like what I'm calling the for this message that we're about to send over. So like for the decimal 0 through 9, or for the binary it's B. I guess you have something else in your C++ coding or your Visual Basic coding that like reads that and then deciphers that as well.
Yeah, that's what I mean. So when I type B0101, the PC side read that as a string of character B, character 0, character 1, character 0, character 1. And then inside the code, say, oh, my first character I read is B. So whatever character coming up are going to be 0 and 1. So I know it's binary number. If it's reading the first character and it's a number, basically a number is what? Symbol between 0 and 9. And I know, oh, it's just a decimal. I don't need to do it. I just send it straight. If I receive a 0x, I know what's coming up will be hexadecimal notation. You had to tell something. Okay?
But that's your code on the PC side that deciphers it, not anything.
No, on the bot,
It's just got
on the bot,
TSG.
on the bot, all whenever you invoke remote control arrive true and then receive a new packet, that remote con TX or RxD, that's a piece of firmware on the bot. Basically receive that whole 6-byte packet, strip out all the header and stuff like that, pull out that 16-bit message. So it already prepared. So it pushed that 16-bit, the actual 16-bit message into WRX data. So it prepare for you already, and it's a 16-bit number. You do whatever you want with it. It's already prepared for that.
And then, how will this program handle if we send something longer than 16-bit, or we never will?
It cannot. It probably truncated, or it just no. Remember is what? You cannot. They have. If you use no. If you use, we're coming back to this one. Don't ever forget this one. Let's see. I didn't have that. Here we go. Yeah. That's the protocol. On the CM5, it expects to receive 6 bytes, and it will do its stuff as planned. If you're adding something more, or if the header 55, FF55 ain't nothing there, or if you didn't invert the data and chop it up into 2 little pieces, it's just junk for it. So if you want to mess around on the robot side also, you need to have the power to go into its own firmware and change this protocol. Okay? So of course, you cannot do that. Actually, you can. They have a library embedded C where essentially you wipe out their firmware, put in your own firmware, your own boot up software and all of that, and you can do anything you want. Okay? Because usually any COM devices are just designed to send out clear messages. Basically, you tell me to send 6 byte, I send 6 byte. And it's up to the receiving end, up to the sending end to agree on whatever. The hardware itself just send clear. Okay.
Yeah, I read some stuff about that.
Yeah. So if you want to stay with their own firmware, this is their protocol. And you see on the C program, when we get into the detail, we stay with that protocol. Okay. All right. So we're done with that. Okay, it's sending over. Okay. All right. So just spacebar. So I finish it. And what it does, the way this one works is I have a log of all those things that I've been playing with into the text file. That's all. Okay. All right. Now that we're done with that, let's look into the detail of the code. Okay, so I recompiled everything, and I made a new workspace for Visual C 2012. And let's see if it's working for us or not. At least it worked for me last week. Okay, loading, preparing. Good, excellent. We pull up, okay? Getting there. Mm. So anyway, let's go into it. From a practical point of view, remember the various file, ZigBee hardware layer. They're all in there just defining. Essentially, remember that. I think of this was this is the part that define the protocol. Okay, and also lower interface level with the Windows, the PC system. So hardware open, hardware close, TXD something, and RxD. So this is the function that actually very low level. That's the one that prepare and send it out at the very end of your very end of this thing, very end when they come out through the COM port, through the PC. Okay, so usually that's what I mean. You don't need to mess around with that part at all. Okay, so you don't want to mess around with ZigBee How. ZigBee also define all the functions initialize to terminate something, TXD data, RX the data. Okay, you don't need to mess around with these either. Right.
Is that INT like so line 14? Is that initialized or
INT what?
like the first init in line 14?
No, in the .h is called header file. In there, you define all the function that you're using in your program. It's not the real program. It's just a whole to that.
But then I guess you're asking for an input variable, like.
Oh, okay. So.
Is that an integer?
Yeah. Well, okay. Hang on. This is just basically these are defining the function, and every function always have input. Okay. So the input output in the parentheses. So this is the function name. ZigBee initialize. So what I will plan later, I plan to use that. It will need one input, something called dev index, a parent dev index, and it's integer.
And it's because I saw on your model you had a floating decimal.
What?
A floating one.
Well, it could be anything anywhere. So I don't know what is the purpose of all this. What is the purpose of the question? If the purpose of the question asking me what is these are definitions. Yeah. It expects this kind of data come in, some kind of integer to come in. And what it does is the in front of it is when this function crunch and does whatever it's supposed to do, it returns an integer. Okay.
But the other INT.
What are the INT?
You see how line 10 has.
Yeah, which class number? This one.
Yeah.
Yeah.
The first.
I already told you. This is a function. Okay, listen carefully. Listen carefully. This is a function name. Any problem with that? Just like a function you create, move forward, move backward, whatever. Okay? If you remember in TSK, when you move forward or backward, you're going to use the speed you set somewhere else. Okay? So in the TSK file, all of those parameters are we call global. Once you define them in the main program, you can use them anywhere. Okay? All right. So that's pretty much MATLAB using too. For strictly programming speaking, that's something called scope. That means you have to define all your variable within the scope of your function only. So that when you design that, it's more portable. Okay? So this is a function name called ZigBee initialize. Okay? What it does is very often some function will need some kind of input into the function. It say that, hey, I'm going to need an integer, and for me, I call dev index. Okay? Just listen, and then we can see a function where, so this one is just defining them here, defining the name. And then you define These are the header for C. This is a header. So they just have lots of name and define. Okay. So like we go back to here, it means that, oh, I'm defining a function ZigBee. I expect it's going to expect to inputting or take as input an integer. And whatever that function is, I define it actually in ZigBee how.c here, which is going to show up. Okay. But what it does is once it's done, I'm sorry, ZigBee.h, let's say, when it's done, this function ZigBee initialize is going to return a number. All the function in real programming, you have to do that because it needs to take some input. Usually it needs some output also because you tell it whether something is right or wrong or whatever is inside, if it's successfully execute that function or not. Okay? Mm-hmm. This one here, ZigBee terminate, didn't need to take anything. And it's void, it means it's returning nothing. Okay? ZigBee TX data. Remember, this one is equivalent to the RCon TX data. Actually, you want to send something, you better have some kind of data. So it will take whatever in data, which is an integer, send it out. And then it's also return an integer. And usually you read that integer when it returned to tell whether it was successfully sent out or something like that. It's always have that kind of code in here. Check, because check is equivalent to that, the flag. So it doesn't take any input, but it does return whether true or false so that you know whether something new arrived or not, right? Receive, well, when you receive, you don't really have input. Whatever receive, you return an integer, and that's your data. So you need to somehow to be something to be receiving end of this function. Okay. Also, the header file also contain all your definition. Because later in the program, if you say, oh, 1, 2, 3, 4, you don't remember it, what it was. So essentially, it pound define here, essentially just assign this name, RC100 button U as a parameter name is equivalent to the number 1. Okay, so later, because when you write program, you're going to write it, shall we say, in human language. So instead of using 16, you're going to see in the piece of code, they're going to use RC100 BT1. So that when you read the code, say, oh, the guy meant the button 1 of RC100. Okay, so all the ZigBee how.h, they just define like that. Okay, so on practical purposes, if you stay with this, you don't do anything. Okay. If you're doing some kind of other remote controller, let's say ever they design a new RC200, where all the buttons are going to have different actual numbers, and you stick more in there. Okay. So so let's stay with ZigBee. Well, let's see. I won't be able to define every single function and go through you, but you were already asking about ZigBee initialize and terminate. Okay. So the actual function, the actual detail code is written in ZigBee.c. Okay. Just like ZigBee.how, you have how open, how close. If you go ZigBee how, they have them. Do you need to go through this? Okay, we're going to try it. So ZigBee how. ZigBee how using function ZigBee how open. It takes 2 input. One integer called double index, that's the COM port pretty much. And the float is the baud rate is the float number. Okay, so that's what, and then it's going to return integer. To closing the ZigBee hardware layer, it's a void, it doesn't return anything. Because you close, it close, and then you get out, you don't need. Okay, and then it had 2 other ones. The hardware layer TXD, it actually an unsigned character P packet, which is basically a pointer to an array of characters, essentially. And also number packet. Remember how many packet number in the number in the packet. Okay, and then how it received essentially the same way. Okay, so these essentially people have to prepare this to make sure it matches the protocol for I shouldn't have erased that one. The 6-byte packet and all that. Okay, and then just go to ZigBee Cal C here. Okay, they always include So on practical purposes, you don't need to mess around with all this. Okay. Basically, we're using the Windows serial programming. So because internally, all the COM1, COM3, and all of that, Windows taking care for you. The only thing we need to know is which COM port you're going to use, what kind of data you send over, and Windows take care of the real detail of doing that. Okay. So somewhere you need to stop. So handle, that just create the handle to the serial port. You don't need to mess around with anything. So here's ZigBee file open. Okay, you're following. If you start getting bored, it's kind of out of your way. I'm just gonna skip because all you need to do just mainly we need to go to the main CPP to see how to deal with it. Because this part here you don't use any. You don't really need to go in there. Okay, but so it needs dev index device parameter. You're gonna see dev index and baud rate somehow in here will be used up. Okay, it'll pick that up, and then it's people wrote they're gonna return 0 file 1. So the one Matthew who wrote this nice to have comments to do. So these are more detail on timing out all that. The port name, 15 character. Okay, this when you run from when you type in that number 3 and they say COM3, it pick it up from here somewhere. So we're just seeing that this port name 15 is an array of 15 elements inside. So first it invokes closing it, and whatever you pick up, remember when you run, you type in 3, it print COM. So the dev index for its number 3, the format for it %D. I don't know if you remember any of that or you ever seen.
Yeah, I just got done doing like a huge
Mhm.
but we use that for now.
So
In the same exact setup.
yeah, so basically this is when it run. When you run it and put in 3 here, yeah, 3 it print that one. This is exactly 26 either one that just did COM3 right here. And then if it's okay, and then it create the file. Oh no, just create the communication line, all that. And then here the more detail here, like you have it start the DCB. Let's see, what was that one? Forgot that. But you remember usually you have serial port, you have to put in the baud rate. 8, no parity, 1 starter bit, no parity, all of that stuff right here. So usually this is standard. You don't have to mess around with any of that. And then has more, if depending, oh, what kind of error, oh, some kind of buff, or is it a COM port error, for a buffer error? Oh gosh, it's all kind of thing. Also some timeout issue or something like that. Okay. Okay. And then if everything is okay, it return 1. I mean, everything hunky dory. I mean, I can open a COM port, communication established, boom, I return 1. If somehow there's an error, anytime that is some kind of if statement, this false, you say go to. So, so once it's open, because communication is tricky. So sometimes something happening, the window doesn't work, doesn't incorporate on hardware level, there are a bunch of error. And then if that, you go to this label, even happen, close it, and return 0. So this function will return 0, say something wrong. And then so it define more how close and TXD. So here it's just sending the packet. But how to prepare the packet, it's in ZigBee.c. So this one is this is just hardware layer. I mean, just right at the border where it starts going out of the PC, right at that border. Okay. And then ZigBee H here, that's a more detail. And remember what ZigBee.h tell that you're using initialize, terminate, TXT data, RX, and RX data. When you use ZigBee.c, you have them here. Right now, they kind of unfold. So if you click on this one, there. So see, it's open. Remember how index, taking a dev index, and you're setting up to 57 kilobit baud rate. That's the float it's passing through here through the baud rate right there. So mainly actually run, it invoke all the function for ZigBee, function ZigBee probably call ZigBee.how.c somewhere. So it's all put that together when it's compiled. So if you want to change around, like if you want to change the different baud rate on your communication, you had to change it here. But this only change the baud rate from the PC point of view. That means from this guy. For the here, you have to go manager and you have to do other things. So default 57K. But for most of the stuff we do, that's fast enough. So if you do that, you have to change quite a bit. And then some of the flag and the data is 0, the number of packet is 0. It's just 0 out because this is initializing. And if everything is go through here, okay. So if somehow you cannot, and it's for this one, it's fixed baud rate. But you see the potential you can change the baud rate, but not recommended for anything you do in this class. So if somehow it could not open that COM port, like for example, yeah, you type it in a wrong one. Actually, we might as well type in the wrong one so you can see. So we know it COM1 or COM3. 10 definitely is not open up to anything. It's a COM1, but then because it can create COM1, but it's where did it go? Who knows?
Yeah, it says COM.
Yeah, it can open to what? COM99 or something. So it failed to open. Oh, when you put yes, it did say that.
Yeah, you had to enter in.
Yeah, it just respond back. Yeah, you've chosen COM10. You say your output. This one is just to write to for file. But you can say fail to open the serial port because there's there's nothing hook up to COM10 or COM10 exists anywhere. Okay, so
See, that's the stuff like I like, learning where it goes through.
then you gotta keep on going somewhere. Flu time, huh? Okay, so that's initialize, and then terminate. Just close the device essentially. This is TSG data. This is more of the interesting part here. So the way you read here, it's reading an integer. Okay. So when you read this code, you're assuming that you have data that coming in as an integer. This one is just design. Oh, it's an unsigned, a character array of 6 elements inside. That's your packet. You're gonna send 6 bytes essentially here. And this one here is quite loaded. 28 is quite loaded because remember the data that you already received as integer. You have to change it to unsigned short because data in C, integer data in C on the PC level is 32-bit. So there's the detail here. But if you want to use it one, these things you don't mess around with because it have to be chopped down. We call it short, unsigned, and then he just call it word. And then what does it do is, because remember you have to, let's put it back. Because remember, 6 byte, each of them 16-bit. And you remember we had to chop them out to the lower 8-bit and higher 8-bit. So data coming in integer 32-bit. I chopped it down to a word, a short with a 16-bit. And then I need to figure out what is a low byte. So this word here that actually contained my data, but in 16-bit format, if you end with 0FF, which are the lower 8-bit, you end of that, it clear out all the top or higher bit. Okay, and I call, and then because it ended that, so we've done that before on even on the TSK side. It figured that one out, but it's saved as a character low byte. Because when you send out messages, you send out a character 0, character 1, character A, B, C, D, whatever you want. You're not sending out a number. That's the protocol. Okay, so why you see it change? So this is a low byte. It's a character. Well, also a character is a, yeah, I kind of cheat. If you remember, a character is, I think it's an 8-bit chunk too. A character is defined as 8-bit only. So these are all data type in C. Probably need to go and back and check all that. So the low byte here, so that formed the low byte. The high byte, you remember what? The usual data coming in and it become a word. And a word, this one here is being shift right 8-bit. In the TSG side, that's equivalent to what you think? Yeah, basically the high byte, we move it down. So that's when we remember we have in some of the codes we divide by that funny number to bring it down and multiply by a number to bring it up. Okay. And so because the low byte is already the right location, we just use an AND operator with FF here to take care of that. So because the high byte is the upper one, we have to shift it down 8-bit first. So this is an operator called shift down, shift right, or shift down 8-bit before I end with FF again so that I can capture the high byte. So now the low byte has the lower byte of my data and the high byte parameter has the high byte of my character. So these are the so on the TSG side, what it does is you take the data you receive. Remember, let's say if the ID is up to 10-bit, you multiply by what was the number to bring it down 10-bit. But here we need to move 8-bit. Let's see. It's okay. Hang on. Okay, remember we take by 4096 basically because the ID was in the lower part. We're talking about by 4096, and if you go to binary, you know that it moved to the 10th bit. Okay, but on the receiving end, oh, that part, yeah, receiving end, you receive it, you divide by 4096 again. Basically, you move down 10 bit down so that you pick up the data, the real data again. And so on the PC side, they create shift function for you. The two, that's a shift down 8, and some of them, when you reconstruct, you have to shift up too. So, you can do. So what is it? Remember what? What is this? Because remember what? If you're putting any number on the programming, it means a binary. So if you want to say 0x means, oh, you're ending it with an hexadecimal, FF. And what is FF? FF is when all the bits are ones. Hexadecimal is what? 0 to 9, A, B, C, D, E, F. Okay? Yeah, if all one here, we don't have, come on. Maybe I should quit doing this. You're not the guy. Or rather, we should not teach MATLAB to real engineer anymore. Let's see. We won't have time, but you can check on it. I need to go on. If not, I'm never gonna finish this. If I have to teach you C at the same time. So this is hexadecimal. So FF corresponds to the first 4-bit being 1. Remember, we go 0, A through 9, A, B, C, D, E, F. So in binary, let's see. So basically, we have what? 4-bit here. You know, it's 1, that's correspond to 1, right? And 10 correspond to 2, and so on. Just make some example here. So when you have 1, 1, that's 3, right? And so on. So when you go up to that far, because it's what? 2 to the power 4 minus 1. So 4 is what? 4, yeah, that's 16 minus 1 is 15, right? So we have all 1 that equivalent to 15. And remember, the symbol for hexadecimal is what? 0, 1, 2, 3, so 9, A, B, C, D, E, F. Okay, so you have 10 symbol here, 11, 12, 13, 14, 15. So this in decimal is 15, but in hexadecimal, that corresponds to the character F. Okay, so FF mean is this. The rest are all 0. So that's why when you do that, you're capturing the low byte. And then later, if you pick up the original data, which is data 32-bit, become an unsigned short, and here you shift it down 8, then you go down to the lower 8-bit, and then if you do with end it with FF again, essentially you capture whatever is in the high byte of the data into this parameter called high byte. So later, if you want to read this program and do any programming with it, essentially, this is what so that you know, but you don't have to mess around with it or anything. So remember here, it defined the packet 6 byte in the packet. Okay. So each character by default will only contain 8-bit. So hang on. So remember we had to send FF first and then 555 and the lower byte of the data and then the inverse of the low byte data, the high byte data, and the inverse of the high byte data. And you can see it right here. First element of my packet is FF. Second element of my FF or second byte is 55. And then I send in whatever representing the low byte of my data. And then the inverse of my low byte data and high byte. And then the inverse. So that's a real code that implement this. Okay, so remember data, you're sending in some kind of data, some kind of number. Whatever you have, 16-bit number. You take it and start basically parsing or chop into low byte and high byte. Now it's ready to prepare the packet. So when it is 32 to 37, essentially prepare the packet. Okay. So from your point of view, if you want to use anything, you actually don't have to don't do anything here. You just make sure you put in the data correctly. This is only if somehow you want to mess around and change different things here, change the protocol. Okay. But then if you do that, you have to change on the robot side too. Okay, but this is just show you the gory detail of what happened when you just simply send in this command remote-con txt. You pick it is only you prepare the 16-bit message here, right? And then you invoke remote-con txt. What remote-con txt? That's a gory detail right here. The bot just send it, and you just use the function txt. So from the PC level, you can see that in the main, it just uses ZigBee TXT data because somebody else defined all the gory detail here for you. Okay, so you don't. So that's why I say the ZigBee.have.c ZigBee. You don't mess around with it. You just go in there and look so that you can see the detail. You want it, but you don't mess around. Okay, so this is basically just preparing the packet here. This command here is actually sending it. So if it's sending it and it didn't, the biggie.txt, you send this packet 6 byte and it's not 6, that's something wrong. Return a 0, I mean there's something wrong. If it sends the 6 byte okay, return 1. Okay, so hopefully your code will always trigger this one. If not, it's gonna have that problem. Okay, So it depends on the code, how people design it. But you see, when you design a code, you always have to tell, hey, did my function terminate okay? Did it do its job? And then you return one. If there's something wrong, then zero. Or you can return any code. So some more people design the function much better if they say, oh, if this kind of error, you return one. If this kind of error, you return two, three. It's up to you. So that TXD does. And check, basically receive this one here, it receive the packet and check to see if all the little packet are okay. You see it figure out the header, remove the data, remove the or if you didn't if you cannot find the header. So basically go in here. The check, you remember, is the flag, right? It's really this. There you go. Here, remote control right. Very simple on the programming on the PC, on the TSK side. All you say is, oh, go read remote control arrive if it's true or false, right? So when you invoke that, the gory details in here. Let's see. Basically, this one here is receive the packet. It has to be less than 6. If not, it's big. If you receive packet more than 6, there's something wrong, right? Protocol here, the problem. And then it's pick up. It start deciding them essentially. This part here is actually check to see if the first one is FF and the second one is 55. Okay. So if you receive more than 2, and then you do this, and then if the I is bigger than 0, you cannot find the header, so it's start doing things. And then remove data before the header here, verify the packet, and then the packet is good here. It's sending that GV receive data, and put the flag to 1. And then it looks like it clear out the packet 0 here, and then return the flag. So if the flag is 1, you return the flag. So all that detail, and from outside we just see something returning 1 or returning 0, but that's the gory detail of that just remote control arrive. You see, you have lots of detail. You have packing, you have to check the byte, lots of data, and then if it's okay, and then you know your data is correct. If not, meh. And then receive data. Receive data, very simple. All it does is just it set the flag to 0. It return the data. GWR receive data, except it's actually massaged a lot in here. And then finally it return the flag and the data, RC receive data, all of that is done. And then this one just return, really. So right now, so basically you don't, HAL and ZigBee, you just leave that alone because we're not messing around with the protocol and how it does a message, okay? So we only mess around with the main, and those go into the detail. Oh, time is past. Well, okay, sorry, 10:30 already. So we'll show, and let me make sure. Sound, okay, sounds good. All right. So it's recording again. So this is the main program where if you want to adapt it or modify it, that's the one that runs. So remember in C, the main program will be, so basically all this here, it will be compiled and put together when you compile the code. And that's the binary that we were playing with. That one, when you do this, binary playing it. So it combines all these C code and all these H code, and it runs. So when you read, when you try to understand the C code, first thing you need to do, and you need to go and to read the main program. So all they include here, you can keep them. You don't need to change anything. So this is the main. So you define an output file because that's output file stream is the file, so it have to do that. It prepare the character so that it know whether to belong to a file or not. It zero it out, and then create a string variable, one for the COM port, one for the out file, because you had to type in the string that corresponds to the output file, right? So it had to save it somewhere. So this one is just initialize it, and then it has some parameter garbage. So two double code means basically to initialize, basically create a SDR COM parameter, which is a string, but essentially zero it out, essentially here. That's some integer we define.
So like, I guess that's how you assign variables right there.
Right, yeah, this is assigning variable. And initialize them to essentially zero. You can use it one at a time and you semicolon. You can do a bunch of them and then it's comma in between. So there's something I call index, I call I. Def index, that's my COM port index. My receive data. Okay, so receive data, it transmits 16-bit signed bits. So I do this. And then transmit is also an integer. So you see he have all those detail here. It receives 16-bit number and treated as sign, and it transmit as sign. So we need to prepare for it. Okay, a sign 16-bit number is a 16-bit number, right? A sign means you need to have an extra bit. The 17th bit is 1 and 0 to tell you the sign. So that's why we have to use an int, which is have 32, so it can pick up all that. But there's a bunch of them up to 1, just 0 we don't use. And then this one is just string theme. This is window character stuff. Remember we're gonna push some keyboard, right? Okay, so it's a character. Anything coming from it is a character. So CAHR, he just happened to call CAHR. It just reversed a little bit, so he named that way. That's something temp and length with integer and zero out. We're going to use an error if we have something so that we can set up the error. So basically, when you run this one, because I invoke it directly from the Windows, I didn't put any input. Remember how you can write a program like AutoCAD space something if you have a command line. If I run this one and I put a 3 in front of it, it will pick up that 3 and put it in. But because I run it like this, I cannot put in input. So, but sometimes, so basic command line. So if you do command line, that's argument 1 will be set. So because you didn't pass any argument, it print out COM. I just show you a little bit, and then we have to go somewhat faster. Basically, see out COM, that means when here stop here, right? And wait for you to input. So when you input a number, it's saved into that str.com. And then it's see out, that means it print out COM, and then the number, and then it go to a new line, and it print out output to file, yes or no. Okay. So that's when let's say when you type in 3, boom, it respond with COM3, go to a new line, output to file, yes or no, and then it just sit there. And while you are not hitting the keyboard, it just stay there. Essentially, that's what the code is. Yeah.
I know that this is a general code for what we're doing, but what exactly will change this code fit our specific things?
Whatever you want to do that later. I'm just going to explain to you how this code works here. Up to you how to define it later. Right now, I'm just trying to explain what these things are. And then how it input how will you put WASD, or when you put T when you send a special message, that's the code coming out next. So for example, if you set, you have to set it up, so maybe S will be your scan data. You send in S, and then you have to ask, oh, which bot I'm going to use on. That's up to you to design later. Okay. So, but need just to understand what is going on first before you can think about your own solution later. Just trying to understand. So at least when you run this one here, you know which piece of the code it's working on for now. And then when you do your stuff, that's later. If you can do that. The fourth project and stuff like that are usually custom to what you can do. Some people can do this, but this is as part of the treatment. You need to know this. And then on some classes, like if you go on the web for the project, one person did this. We have two person. They work together to do this. Okay, so we'll see. So you see why a keyboard hits here, and then as soon as you hit yes, let's say, gets character, it gets the character from the keyboard, it's saved to that parameter here, and you can say, oh, if it's small y or capital Y, essentially, and what do? You ask the user to enter the file name. And then as soon as you can enter the file name here, in, pick it up, save in str file, and it print it out again for you. And it set the block to file equal 1. So basically it's a flag so that you know. Okay, so you better enter in test2.txt. You pick it up, it's C out. I mean, it responded again to me to see. It said block y to 1. And CL end line, that's why it goes to a blank line right here. I see that's a blank line. That's CL end line. So 61 here. Okay. File open successfully. Else, you can get up to 4 port name and then here. But it pick that up. Remember when we play around with the wrong COM port, it couldn't initialize the COM port properly. It's gonna say failed open serial. But if you equal 1, okay, it print out the file name, and here that it does. Basically, all this part here is just open. You create up. You put in test2.txt. It responds that. It actually finally now it create a file on your actual folder. Say test2.txt. Send it to Windows. Windows create it. Windows respond back. Say okay, I created that file, and it's keep it open so that you can input in. So all this thing here, you just open the file. You don't need to do anything. And then it check to see the file open successfully, blah, 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 on that, okay? And then finally, so if you get here, if you see the quit press paste key, it opened the file and everything correctly and just sit, and then it's just waiting for you there, okay? And then the rest is the big code where, and remember when it say WASD, if you push T, it goes into all of that. That's the big code remind. Because while one mean what? Endless loop. On the PC side, on the TSG side, it's a while loop. And if you put in there, it's true. While you put 1, it's always true. Okay? So 142 here essentially correspond to the equivalent of endless loop on the robot that you've been using. Okay? And then endless loop means what? You're going to go through this whole thing, and then it go all the way down pretty far. So 143. Here we go, right here. It ends 498. And then you can see that this is a label. File 1 is label error main. So if something error, it's send it come here. Basically, you can see it. Close the port. If the file is open, close it. Press any key to continue. Good written. Okay. So return 0. So this is only when somehow your main, you always have like a section where if something goes wrong, and what you do is you clean up yourself from, because you are dealing very close level now. You terminate your communication port, you close the file. If you don't open the file, well, sometimes it happens. I'm sure you got happened before. Like you're in a Word, you do things, and something go bonkers. You know that you cannot recover that file because it never got a chance to close it on the hard disk. Okay, so these are just take care of things there.
So would you like make it ruin a serial port for a little bit?
Yeah, if you didn't terminate, who knows, stay up there for somebody. Yeah, so when you run the program again, though, it's initialize it and establish communication again, so it won't matter much. But this is just a clean way to do things because you are dealing very low level now. Okay, so that big chunk of code right there. So that's just check of one as an example, and then we need to do the rest next time. Okay, so that's a big chunk of code. That's the part that deal how you type in WASD and how you send it away and all of that. Okay, so that's a big endless loop. So if you hit the keyboard, that means if this becomes true, that means you hit the keyboard something. Obviously, what you get whatever the keyboard is, you save it into CAR. Okay, here is commented out already. If you hit the space bar, you just break out of the loop. Right? Nothing difficult there, right? If you happen to be pushing small t or capital T, and then you go, it's do the custom packet. Okay? And so let's highlight this one. So let's see. So that's just to deal with the special packet. And whether you do it in hexadecimal, that's a big chunk of the code. Let's see. I'm just trying to find the one here. Okay, so that's the end of you read it. I mean, it have comments. So that's the end of big chunk of code when you push in T, because you have to remember what if you push T, and then you have to enter. It show the 18-bit message, and you 1, 2, 3 or whatever, right? Okay, so that big chunk of code is taken care of up to the end here. And then remember, you can push in either WASD or something, right? So those are a little bit easier. And I can show you today, and then we'll take care of the big one next time. So if you push WASD, because that's equivalent to the up button, wasn't it? And that's 1. And remember what? We have to prepare WTSD data as an integer. It have what? 4 byte. And then hexadecimal, so 00x1, and have 1 happen just to be, like 1. And then remember that TSG data function that we have found in ZigBee.c? We just use it. So we finally get to use it. You set up the data. So as far as you're concerning, if you push whatever, prepare the data, ZigBee TXD data. It's no different from when you do from the CM5, so from the robot side, okay? And then the add, and then you see more comments and stuff. So we'll stop here. Okay, so hopefully we'll go over the detail of the main program today. So remember what? Just a recap: ZBCal.h, all the include file, all the header file, and then also all the ZigBeeHow.c and ZigBee.c. They are, shall we say, in a way, low levels. Take care of the actual driver and COM port on the Windows side. Make sure everything is a packet is the right side and send it away. Okay. So for you guys, when you modify it and use it later, basically you need to concentrate on the main. So on the main program, as you see it's defined here. Okay. So when everything put together, all these CPP and C.L are put together into this EXE or the executable. And right now I'm running that one there so you can see. And probably best to explain that we alternate from one to the other to see how I input from the screen and the keyboard, how the main program picks it up. And then that way you can modify it for your needs later. So here this one is just 15. It pretty much just defined it as an output file called parameter called out file. They use a character belong to a file 0. It's not recording. It's 1 is recording essentially. Create some string variable so that we can output it out. The string com, string out file. These are the things that you're going to input from the keyboard, because you have to name what? You have to name your com port. You have to name your output file. So those are string parameters just to get ready to receive the data. Oh, it's gone again. Yeah, it's in the tools option. Let's see, go to text editor, all languages, and make sure that line number there is checked. Look like it. Yeah, because you guys couldn't save anything on your desktop, so every time you had to redo that. Yeah, text editor, all languages, and then the line number. Sure. So define value, other defined indexes, we could use I something. Def index, that's an integer, that's come to 1, come 2, come 3, whatever you need. Like for example, if I don't knock it, let me stay away from it. Come 3, I'm going to eventually. And then just as you remember, you had to prepare a message from task program. Okay, this is called the parameter I'm used to receive the data. And this is a variable that I'm going to use to transmit data. Just like you define in there, whatever message you have, messages and all that. This one here just to set it up. So input string and output string, that this is C++ specific. You don't even touch that one. Character, because I'm going to pick up something from the keyboards. So I'm called a CAHR. It's a character because it's going to come into the character. So right now, this program is set up so it expects you enter only one key at a time. Okay. So if you want to enter like more, that's called a string. You have to, there are other functions you have to prepare to do that. If you read in the string, there's as you hit one, it picked it up. So that's something called temp and length for the keyboard, some error parameter. So when you first run, because you didn't, the program didn't put any input, so argc equal 1, I mean, they didn't have any input on the command line. You see it's cout com, and then it's waiting for you to enter the number 314 or something like that. So that's why you see it just have com and the cursor stop there. Okay. So let's say for my case, it's 3, so I'm going to enter 3, hit it. Okay. So it pick up 3 from string com here. C in means to get data in, and then I reprint it. And then I ask you output the file or no, yes or no. Okay. And then this while here is while exclamation point is equivalent, if you remember, even from inside task file, I mean equivalent for not. So while the keyboard is not hit, that means you didn't do anything. It just stay there. It didn't do anything. See the curly bracket? You kind of put closed in other, but there's nothing in it. So basically, this is equivalent to wait while in task program. Wait while you're not hitting anything, so or no input from the RC100, or the flag it remains false. Same thing, same idea. So eventually, you're gonna hit the keyboard. The get character function here pick up the keyboard, whatever you push and put in CAHR essentially, and then it's checked. Did you push yes? And then it's gonna give you a prompt, enter the file 9. You put in the file 9. It output out it for you, and it set up the flag to 1. I mean, hey, I'm recording something, and just give you a new blank line. Okay. So here, wrong one. So if I answer yes, you see it pop up this file name, right? Wait for me to enter the output file name. So I'm going to enter whatever, test number 2, that text, for example. Okay. So when you put that, whatever you type in, it's saved into string out file. And then it's going to print it out again just to verify it, right? So that's what it did. Okay. And then it say print open file successfully, quit specify to the key. Okay. So when it's got that, this is a case when you do input on the line. So you can type in, this is rarely happen because you have to go to the DOS command box and type in PC data logger.exe, and then you have 3 into your file name. Basically a single line command. We don't do it here, but usually when you program, you have this in here too, just to be thorough. It's command line. Okay. So this part here, you probably don't have to touch anything at all. This else part you don't have to touch. If you pass some argument and then use them, if not, nah. So and then all it does is there's a bunch of things that it does in the background. It doesn't display. But it takes the string, it converts to an integer because what you enter when you enter 3 here, you really enter character 3, not the number 3. And Windows understands the COM3 as COM numerical 3. Okay, so that's why there are a bunch of things here. You have to initialize it, and then remember all these ZigBee initialize that were from ZigBee.c. So I initialize that COM port essentially. If something happening, it's gonna fail to open the serial. Like for example, if I push COM1 and not using COM1, this message will come up. So you can take this at home and play with it, and then you pop this one up, and then you try different things. What happened if I answer no? Or rather, what happened if I answer wrong COM port here? You can see where it goes, and it'll give you messages, error messages. You can see how it works. Or if you answer no, I don't want to open any file, see how it responds. Or if you put in and somehow could not create the file and all of that, it will do. Okay, but eventually you see this one here is it opened the file okay, and it's there. So it's way down here. So basically these things here is this is to take care when somehow it cannot open that COM port, which happen when you give if your dongle is on COM3 and you tell, oh, I'm on COM1, it's gonna say, hey, I can't find anything. And then if you want to log to a file, which means b log to a file is equal to 1, and then it start preparing the actual string to go to whatever places, and then it opens it. Okay, so that's what it does here, and then it opens the file. So this command here to create a file of the name that you are given onto the window somewhere. Okay, of course it can be open okay, it cannot be open okay. So it's open okay, it print this one out. That's why you have C file open successfully here. It could be that it cannot open, like you're writing to something that you cannot write to, or you tell to write to a thumb drive which you didn't have inserted in, or D drive and you don't have D drive, those sort of things. It will say unable to open the file, and boom, it goes to error main. And error main is way down at the bottom here. Basically what? It close up, close the file, see out, say, hey, something wrong here, guy, and then it quits pretty much. Okay, so we have always error message to catch those sort of things. So let's take care of that. So this whole section here is now just to preliminary input and chat and working with the user. And then you can see that 140, press quit to space key. That's where it shows. Okay. So if you follow the main and the example you run, you can understand how it works pretty well. Okay. And then while one, and I mentioned to you before, while one, that's endless loop inside task program. Because while one, I mean while something is always true, that means it's gonna endless loop. Okay. All right. So right here, how does it work? So right now here, if I put W, it immediately transmit one and say up ASD, it will do that. So it's sending over and it displays something here, okay? So that's what it does. So it's true. So it loop all the time. And if it sends that you just hit the keyboard, one character, you see it pick it up and save in CHR. Okay? And then if CHR is nothing, which is the hash bar, you want to quit. You don't want to play anymore. That's all. Okay? So if you want to play anymore, you break out of the loop. And if it breaks out of the loop, where does it go? Because that's a big loop. It goes to essentially error main and close up out basically. Okay. Okay, if you remember we played before, if you do T, well, T is this part here and it's pretty big. So that's a big loop. We'll take care of it a little bit later. Okay, so it's because that's when you do it in decimal hexadecimal or binary and stuff like that. So that's when you receive. Let's see. This is when you do 1, 2, 3, 4, 6. Here we go. We just play around with WASD, right? So this whole thing, big chunk here, is a bunch of if, else, if structure. Okay, that's right here. Is if somehow you're pushing W. This is how it's handling it. This is how you pushing S. It handle how to handle it. This is when it's A. This is how it's handle it from here to here. Okay. So you can see and then all if you do 1 and all of that stuff. So you can see that's how you can handle different input key. And then, for example, later, let's say you have a character D to disperse all the carbon, and then S maybe to mean, oh, I want to scan one of them, okay? Because right now, the way it's designed is it pick up only one thing. So let's say you put in scan, well, we have 3 carbon, and then inside of this, you have to pick up on the keyboard again because you have to, which one? You have to ask, hey, which one do you want me to scan? So you can just build up on that a little time. Okay, so let's say you push W, and you can do W or capitalize W, usually because sometimes, the cap locks keys on. And then what do you do? That time, because that's equivalent to the old button up, so that means it's number 1. And what is this number? It's really number 1, but in hexadecimal format. So it's a 0x and then 4 bytes, essentially. F, yeah. So because we want it's to simulate like the RC100, which is really sending the number 1. So it's number 1, and then just the same thing. Once you declare your parameter, you just use ZigBee TSG Data, and boom, it goes. And remember from last time, it goes through, it prepared that little 6-byte packet with FF as the header, 55 header, and then it's sent it away to the component and all of that detail. But you don't need to modify that. But that's there because you can see that you can modify your actual communication protocol. Right now, we're just using robotics protocol, so we don't mess around with it. But you see this open up your power to make your own protocol. Whatever you need to do. Okay, so and then it's just see out the transmitted data. Like for example, if you push W, it say, oh, I transmitted 1, right? Because that's TWW data now. It's transmitted 1, and it corresponds to up. And then this next line here is, but C out means to console out. That means it will print out to the little window console here. And then, because we sometimes remember what? Sometimes you want to print it out to a file also, right? Okay, so they have to use our file. And this is what it displayed out there. So let's see. So the test2.line, oh, yeah, you won't be able to see anything in the test2.file now because it's not closed yet. So basically, whatever it's transmitted here, it's sent here to the test2.txt file also. So that's your record, that's your log.
/T with the
That's a tab. /T is equivalent to a tab. /N is equivalent to the new line. Go down to the new line. So those are the basic ones.
And then I guess lesson, those 2 lesson signs, we put the
Which lesson?
or those out like those right there.
Okay, that's just a symbol, meaning you prepare this whole string here and you send it to the console out, which means, hey, send it out to the window, the little black window. And then if you do this, it means send it everything out to our file. And our file happened to be your test2.txt. Yeah, so this is just input and output. So you notice it's input when you pick up the character, which is way up here. You get the character. See out from the right to the left. Just same thing, right? When you do printer print line, you have printer print line on the left side of the operator, and then whatever you have is on the right side. So same thing here. The symbol is just different. So C out means outside it. He says a C in. Here, like when you're waiting to enter the file name, you stop here, right? And you type in test2.exe. When you hit report, you require the enter key. I mean, whatever you type on the keyboard, which is console in, it's saved into that the name of the output file, and then use that to open the test2.txt file for you later, because that's when you enter the text. Okay, so that's so that's how they treat it. So you can see that, let's say if you have another, you create another, when you enter whatever key you decide to do later, you can create another block of code for yourself. And you can massage the data, insert thing, insert ID, insert whatever. That's your piece of code here. You do whatever you need here. Because what it does is deal with the S case, with A case, with D case. And then here, if you press a 1, I mean, there's all kind of comments in here. So, okay. So if you push 1 on the keyboard, okay. So we're sending a 1, which is equivalent to a hex is in 10. Okay. Like, for example, if I go back here now, if I push the keyboard 1, so 1 0 is this is in hex. So you can see the equivalent in decimal is 16. That's a button B1. And you can see that output the console here, and also output to the file so that you have a record. Okay, so you can see that. So basically, just you can see that just the same thing really. It's not a whole lot in different than really in TSK. In TSK, you prepare your message, right? Whatever you do with it, and then what? You TXD the data out, which is use this command. So the logic is still the same. The rest here is just basically use the feedback so that you see on the screen. Okay, so it's up to you. You can use this, and you can do shift and the other operator, whatever you do to massage your message. And when you're ready, hey, boom, just ZigBee TX data, whatever your data is, whatever your integer.
What's the data number for like all like TSK file?
You can look into the TS. It depends. If you want to emulate what the RC100 do in TSK, all you have to do is just go to TSK. Remember when you click on this, it shows. Let's see. Like for example, I'm just gonna put it up. We won't need to run it, but here. Oh, let's say COM1 so that it's happy on it. Yeah. See here? Whenever you push it, it will show. Actually, better in here. Yeah, this one. RC button. Up, you see it show the number. Down is really 2. So what the 1 is here is really 16.
Yeah, I know that. I'm talking about on this, like 1 is like.
Oh, like 1 is just character 1 here. Here. It's character 1. So you push a number 3, it's character 3 on the keyboard, if you use the keyboard. These are the data that come from the keyboard, 3 and 4. That's what the keyboard gives you. Oh, something loose?
Yeah.
What would be for all of them? 0, 4, what would it be? What do all of them? What would they know?
Oh, and then you can. It's up to you. That's like I said. It's up to you still to do that. And if you don't, no. Okay, hang on. You can explore that on your own here. Do you want to be equivalent to it? Just check them all. And you can see the number down here. So you push everything, it's 1023.
Yeah, but that number isn't the same as the other number that's on here, though.
I guess what I was trying to say is, on our carbot, how we could go up and left at the same time.
No, this piece of code right now is it designed to pick up because of the way it picked up is the way the code is it will do nothing as soon as you touch the keyboard here. If the keyboard got hit, it pick up character. So if you want 1, 2, 3, you push all of them together, it won't be able to handle that. Not this piece of code. Because or you cannot even type continuously because you look at this here. Let's say if I want, let's say example, if I want to push in 1, 2, 3, I'm going to push 1, 2, 3, 4, one after the other one. It pick up 1 immediately, it pick up 2 immediately, pick up 3 immediately, pick up 4 immediately. Okay, and that's the code does it. So that means what? If you want to do that, you have to prepare yourself. Oh, character 1, get it. Character 2, get it. Character 3, get it. Character 4, get it. And you have to put it together as a string. And then instead of and then you have to prepare it yourself. And then let's say you have a case where you say, oh, yeah, it was like that.
Yeah, but what would the WTS data, what would that
And that's that you have to define your own. Okay? So right now is if you go back, because we are trying to simulate on the PC the same thing as the RC100 virtual, okay? So it push 1 in here. How do you know? Because if I push 1, which is this here, it's 16. So because I want to emulate that, I want to emulate it, send out the number 16. I need to send out the number 16. And the number 16 happens to be 10, 0 in hexadecimal. Look, now I'm going to push 1. You see that?
But I know number 1 is corresponding to 16. I know number 2 corresponds to 32. What I'm asking is, how do we know the hexadecimal number?
Oh, you look up Wikipedia. You look up a book somewhere that convert decimal number to practically any C programming book, basic programming has a table in the back. The number 1 is what is a number? What is a binary for number 1 is? What a binary 2 is equivalent in hex. You also have calculator that will convert that for you.
And what I like to do too is it's kind of easy. You open up like this,
and
like what you did on the Robo Task Manager, and then so you go to your number, type in 10, 20.
Also, you don't have to look. Okay, he happened to be using hex. There's nothing wrong with this. Okay, you look and see it. There's nothing wrong with this. Because from the TSG, when you push 1, it's really not sending the number 16. Okay? So if you don't know your hex, just use the decimal because it merely means 16. It won't do anything different. It just means that, hey, whatever your number you are doing here, because I have 0x up front, so the computer knows, oh, whatever is coming up next is in hexadecimal form. If you don't have anything, it knows, oh, it's a decimal, 16. And then what it does internally, it really converts it to 0 and 1 and send it away. Okay? Later, when you see, so if that's bother you, yeah, don't use this hex. Just use this, that's fine. Or whatever message you plan to do. Remember how you multiply, divide by that magic number to bring it up, bring it down? Same. Okay, this is just a different, in task program, it doesn't allow you to represent your numbers anything except as decimal. On the C side, Visual C, they allow you to present anything you want. Okay, so that's what it means really. Yeah. So for your case, hey, if you don't know hex, you just do that. That's fine. It's working. Because the key idea and the key idea to remember is we want to simulate the virtual RC100. So basically, this one handle, 6 up to 6 and stuff like that. Okay, and then if it's bigger than 0, that means you send an empty packet. So you set it to go to 0. So this 0 here, because it doesn't have 0x anything in front of it, is 0 decimal, which is 0 in any any database, and any hexadecimal binary anyway, so it doesn't matter much here. So you're setting 0. So it's sending an empty packet to make the RC100, because every time you release a key, it's sending, you don't send anything, it does that. So what does that mean? So if I put any other key here, I put anything here. Oh, I have put about the key. So anything, push anything except WASD and T, it will transmit 0. So that you simulated it. So now because I pushed T, I have to answer. And this is and just leave it here for now. So when you end, if you somehow, instead of playing WASD or 1, 2, 3, 4 through 6, you happen to be touching the keyboard T, 1 T or T. In here, he prepared that so that you can, all this code is, you're preparing a custom packet. And a custom packet, like here, I'm going to send out 1, 2, 3, 4. That, because this is a decimal, I just enter the number. See the prompt? So I'm sending 1,234. And you notice what? This one wait. It wait until I finish inputting the string, and I have to hit the enter key in order to pick it up. Previously, anytime I do WASD, immediately take it. It goes in because it's defined to pick up any character. As soon as you touch the keyboard, it will pick up that character. So now I'm sending 1, 2, 3, 4. Oh, I didn't run my end here. So it's supposed to beep. Actually, time to put that thing back up, really.
So we could really hack, like, if we wanted to do like that car bot where it does forward and turn at the same time, we could, I guess, really hack up this code right here at the T part.
Yeah, it's up to you. You can have up and left, up and right. You just define it differently here. Yeah, it's really because you are designing your own code. You have to set to your protocol that, hey, on the PC side, I always enter 1 character at a time. Just send it over. It's up to your task on the TSG side to assemble that. Or you say, oh, wait a minute, I want you to assemble on the PC side first before you send it over. And then over on the TSG side, instead of just you here, you can have you and right means something. Hey, it's up to you. It's really up to you how you want to define it. It's really, yeah. Yeah, you can have your case when you have up only, you have a case where you have up and right, you have a case up and left, whatever. So it's up to you. So it's real.
Q is a bending, a forward left turn.
Yeah, whatever. I mean, there's except the only thing is the simple keyboard here doesn't know how to handle all the F keys. F1, F2, they cannot handle. It's just simple key, only simple keyboard. Other than all the numbers on top and the alphabet, it cannot handle function keys. It just at this level. I mean, it can handle. I'm sure like Word, it can handle function keys, except not in this development. That's all.
Because we're only loading in so many.
Yeah, because we're loading specific things. So I think it's something on string and console I/O or standard I/O. So because this is simpler definition, it won't be able to handle that. That's all. So if you are dealing with, but obviously if you're dealing with actual window application where you have actually like window coming up and then it's just more. It's just more stuff. Okay. So,
Because I was looking for an
right. So right here, let's see. So we do WASD again, right? So let's do that. Okay. And then if I happen to push, I'm gonna push T button. If I detect I'm pushing T button, it displays this message. Okay. So it's happened if I push T button. This is a case here, and it's a big case. It's very complicated. So first you see it's CL. Hey, enter the 16-bit message, and then basically this is it's a whole big long prompt to show you that hey, you want to print out inputting a binary number, use B in front, and then put your zeros on 01. If hex, it had to be 0x and blah blah blah. Okay, so it does that. And now you see it's different now. It's C in the whole string. Okay. Instead of using get character, because get character means get character, right? Get whatever key you input in. So in C here, it's one, so that's why it can only handle either T or capital T. But inside of that thing, you need to enter a string because you're going to enter a bunch of number before you hit the character. So that's why they're inputting a string. Any problem with that? So that means that's how you're going to input a string instead of a character.
And some of these functions are, I guess, predefined as in the like the
Yeah, all the C in and C out are predefined.
and then like the get character, because I didn't see that.
What character?
Like you know how
Get character is already defined, and then
that-
get character is provided by Visual C Express for you already. That's one way to put it. Okay, CL is already provided for you. So all of that, yeah. So, but the thing is, you need to prepare them. Like you have an output file, right? That's an output file kind of string or stream. You have to define that so that it knows that you plan to use to do that. This character belong to file. WRXTXD, the character that you're gonna pick up from the keyboard, there it is. Okay, and then remember the string garbage. Hey, it's hey, I'm gonna use something called string garbage, and I initialize to blank, nothing. So all those things you have to define.
And where are the preloaded? Like where could we find the list of preloaded functions?
Written in the C book.
Okay.
So like this is here. I mean, it's a string character, a string variable. So that's already predefined. So that the C any regular C book they say, what is the float? What is an integer? What is a double? And all of that. Yeah, I mean that's just basic syntax. You need to read up on a C programming book, which I have plenty. You need one, some beginning one. So those sort of things. Okay. So it's output the message, right? So that's why you see it here. And then basically whenever you see a C in, it's waiting for you to enter something through the console. There's an input. And this is because I'm picking up a string now. You see that it's waiting for me. So if I want to do a hex, the prompt say, you need to put 0 hex and then your hexadecimal number to it, which is, for example, ABCD, which is perfectly legal for a hex because those are characters in there. Okay, and when you hit it, so ABCD in hex is really 43,981 in decimal. Good to know, I guess. Anyway, so it pick up the package and then it's first initialize the error flag because hey, anything could happen. Okay, and then the whole thing here is to parse it. Okay, so when you're putting a string as far as inside the C programming, a string is just an array of character. Okay, so therefore, if you remember how an array is defined, the name and then square bracket and then the index or the index inside, right, and where you at. So, and everything inside C, remember, it start counting from 0, not from 1. So string garbage, element number 0, which is the first element. If you found out that, hey, the guy put in B, hey, they want binary. Okay? So essentially, this is a piece of code here. It says, hey, if it's B, or capital B, okay, we are good. And also it's checked. Oh, is the X element either 0 or 1? You know this guy did enter correctly because he say B and then he just enter a bunch of 0 and 1. He doesn't enter A, B, C, D in there. Okay? Right. So if that's good, you say, hey, this is potentially is a very valid statement. Okay. So we go back to here. If you say transmit again and you put it in B, but then you do this, ooh, that's bad syntax error. Okay. Yeah, it will find the error line. So if you are doing B or B and you look like at least from the first three, so the first character is B and the next character, which is element number 1, is either 0 or 1. Potentially, this is a valid string that this guy just playing with me here, right? So but the thing is, you notice is what? I can do a hex again example. I can do just A. You know how to handle that, okay? If I enter A, B, C, oh, because enter O, not 0. So I have that there, so 0, X, A, B, C. Oops, sorry, I didn't put T. I didn't put T. So 0, X, A, B, C. That means instead of only one byte, I put in 3 bytes instead. But it know how to deal with that too. Okay. So this is the thing here. When you enter a string, the computer need to know how many characters, how long it is. So string.length is basically, and you know that the string garbage here is actually a variable. It could be 1 character, 2 character, 5 character, whatever. But as just long as you say .length and you save in there, you know the length. Okay. And then it.
The string garbage is so you put like .length behind something.
Dot what?
The length function of that.
Yeah, it's a function. No. So notice it's first we'll get back to that. But the prompt says 16-bit message. Okay. So therefore, no matter what, it's going to be 16-bit. So, okay, so that's key thing. Hopefully the user will follow it. Anyway, let's go back to here. This is a variable parameter. Okay. In C, the data structure tend to be very complicated because it have all kind of formation for it. If you say throughout.length, it means I want to know, it has its own function inside. It will figure out the length of that string for you. And so on the right side here becomes some kind of number. And it's saved into the parameter called length. And now you can use the length to check. Because we're expecting only 16-bit, that means 16 character. That length better be less or equal than 17. Why 17? Because usually no, because of this. Huh? No, you put in the 16-bit. But remember, this is what it does. And then remember, we have the efficient enter key. That enter key is also picked up from the keyboard. Okay? But this 1,234,569 in decimal is more than 16 bits. So it's going to respond arrow out of range. So somewhere in there, we're explaining that. Okay? So you cannot more than a 16-bit. And 16-bit, pretty much, if you want to check it, 16-bit is what? Is 2 bytes. So let's say, so if we enter 0x, so let's say if I enter this, A, B, C, D, E, that's perfectly legal. But that's more than 16-bit there. Okay? 0, okay, oops, sorry. T again. 0x, A, B, C, D, that's 16-bit. Or the highest 16-bit number that you can do is 0xFFFF. That's 65,535. Yeah, the word broadcast in there. Okay, got it. Okay, so the more you the more you play with it, you can see how the code is made up. So you check on that, and then this part here is it gets the length, and then essentially it has a for loop go from 1 to less than length, which is essentially going to go 1 up to 16 essentially, right? Because length is 17. Mm-hmm. So it go from 1 to 16, which is exactly the 16 bit we want. Okay. Uh, and then it's deal with each character at a time. And this is basically this is building up the data. So this is, for example, this is case B, right? So you're entering B. So you're entering B. So B 010101 or something, let's say, okay? So you enter character B first. So that means what? The element 0, okay. Let's leave it here for the moment. So the first element, which is sub-0, is definitely B, and the rest 0 and 1. That's why you can see it start from element 1, I equal 1, element 1, because your element 0 is that character B. That's not your message. So start picking up the first element 1, which is 0 here, element 2, which is 1, element 3, which is 0 again, and so on. So they pick up these things, and and because of the dot length, you know how many loop, how many for loop you need to do to pick up all the stuff that you enter, even though the user enters something that sometimes is short string, sometimes a long string, right? But because of dot length, you know exactly how many gonna be there is. Okay, so when you hit this, it know how to pick it up. Okay, and this is how it does it here.
Is that I plus plus right above where your cursor is that tells it to go all the way?
Right, when it's finished the loop one. So basically, okay, this is basic stuff you need to review. So a for loop meaning is you need to loop it for so many times. So it starts from I equal 1. So the first time go through the for loop I equal 1. That's why string garbage will be sub 1. That means it's picking up the first number 0. Hang on, I know what you're asking about. Okay, and then the for loop, just a syntax say, oh, you need to go so that until I had to be less than 17 in this case, or whatever length is, 5 or 6 or whatever. So it's going to go from 1, let's say length happen to be like 6. So this for loop will go 1, 2, 3, 4, 5. Because 5 is still less than 6. As soon as it gets 6, it quits it. Okay. And then, so that's just to take care of how it goes in. And then what it does, a for loop I designed so that it will execute everything inside the for loop and then come back. Every time it come back, it increment I by 1. Okay. So when this loop is executed, it will execute I equal 1. Next time I equal 2. Next time I equal 3. Until I equal length minus 1, essentially. Huh? This one, I plus plus. Yeah, that's a short for I increment by 1. I minus minus. Doesn't exist. It probably give you, and when you turn a compiler, it says probably syntax error. Basically, remember, these are just like piece of code for a compiler. If it's, yeah, so basically this is just I plus but increased by 1. But basically, when you apply this code, is basically what you can see the code is what? Get in the string, check if you need to check this. But the basic thing to remember is pick up the length and then define a for loop so that it can parse each of the character. For example, if you want to print S and then the space and then the ID of your bot, that's how you start doing it. Okay, or you can even have S and then the next character should be the ID of my bot. Next is whatever, I don't know. It's how you need to kind of sit down, and there's a paper up on the web already on the I sent to IEEE where essentially this show our protocol how we handle it. You don't have to do that, or you can follow that and define. It's really just flexible because boil down to it, you're going to send over a 16-bit number. How you massage that, what does that mean inside is up to you. Just like you do on the task program. So that one, so this here is essentially go through the string one character at a time. Okay, trying to convert those characters that you put in, which is really a bunch of 0 and 1, into a single bit, because he had to prepare the right number to send over. Okay, and the key number thing is, and you get it up. These are character 1, 0, character 1, character 0, character 1, and then so on. So you need to convert to a real number inside the memory of the PC first before you send. And so that is his piece of code here. Okay, so if it's 0 or 1, hey, that's a really, really binary notation. Good. I'm going in and I shift left by 1. Okay. Shift the data left once, or if you don't want that operation shift, you multiply by 2, the same thing, and add the next bit to it. Okay, every time it adds the temp first is 0 or 1 here, right? Okay. So WTXD first, that's the data that you plan to do. WTXD is what? Is 0 out first. WIXD and all that are 0 out. So it's already 0 out. Okay. So WTXD is all 0 out. But you're trying to inserting the very first number, isn't it? Because the first time you go through IQ 1, you are trying to inserting this 0 here. Okay. So you end it with this one, because you see this is 1 bit, you're going to put it there. So basically you're preparing the W2XD by putting 0 to it, but you remember what? 0 is really a higher bit. But the way it is every time you enter into number, you actually enter the very low end byte. So you enter the first character into that, and you shift it up to get ready for the next one. And then remember what? This one is going to go through 1 to 7, to length minus 1 to be exact. So read very carefully, because by default, when we write B010101, this first 0 here, we meant it to be in the highest bit. Correct? Because the lowest bit, or rather, when you enter the keyboard, you're typing the high bit first, and then the low bit later. Okay? And then you hit return. When this thing, when it's reading the whole string, it's reading the whole thing like this. B0101. So the first element of string is B. Second element of 0, and so on. So it basically, when it reads in, it's reading the high bit first. And you are processing the high bit first. That means what? But the thing is, when you end with this, you just put in that location. You have to shift anything. Anytime you enter 1 bit, you shift the data that you already have. Remember, this one is what? This kind of tricky here. There are 2 parentheses, isn't it? And if you remember in programming, what? Parentheses, you do everything inside parentheses first before you do everything outside. Remember that rule? Even in MATLAB, you should remember that rule, right? The precedence of it. So this one here, okay, it pick up the first element into a variable called temp. Okay? So that means for this particular case here, it pick up the first 0 here, which is really the high bit of your number. But it's 0 or 1. What it does is first, it had to do what? Everything inside the bracket first. So temp is going to be 0 in our particular case, isn't it? When you end temp with 001, it become what? 0. That means it kept the same whatever input in it. If you happen to have 1, when you end at 1, it's going to keep 1. You see that? But it's in the lowest bit though. It basically we have a situation where you are picking up the highest bit or the highest character, and right now you are putting into the lowest bit. Okay? So you need to do that first. And then you have to shift it to that one. And then you also, whatever your WTXD the first time is what? Is 0. It's all 0. You shift left by 1. And when you add this one in, you have it there. Maybe I should do this. Let's leave it in, capture that, so we can write it in. So there are two operations that it's doing here. So remember, in our particular case, hem is really just 0. Right? So when you end with 001, it just stay there. Okay? WTXD the first time around is really 0000. What it does is, whatever number you have here, you shift it by 1. So whatever it's probably best to do so. So there are two things. So this is WTX data. Fortunately, it just, let me keep just 1 byte, okay? So to keep it working. So the first one, when you have is I equal 1. But I equal 1, unfortunately, corresponds to the highest bit. But when you processing it, actually it's entered here. It could be 0 or 1. Okay? So in order to make, eventually you want the WTXD data, okay, you're inputting this. You're entering 0, B 0101. So this is your I equal 1. It's processing this. So it put in 0 here. So if you have this and you add them together, this 0 going to stay at the lowest bit, which is not the right position, although it's the correct data. Okay, that means what? You need this one here essentially process the newest bit and then put it somewhere in the temp number at the lowest bit. This operation over here is, hey, move over to the left 1 spot, guy, so that I can add in the new data for you. Prepare the message. So it becomes like this. So first time around, this WTXD data, just a big picture, TXD data, the first time it processed all 0. Okay? So when you first did this for this operation, it shifted over this side, so this one disappeared. So it put in the 0 that you inputted right here. First time around, go through the loop. Second time go through the loop, it picked up 1. But it shift all this. So this one shifted 1 time. So it shifted, this is 1 time again. So it become 0, 0. So this 0 here that you inputted is really moved to here though now. Now it's putting the 1 in. You see it? Okay, and then these are disappearing. So and then next time around, it pick up this 0. And before it move over here, it shift everybody over, so become this. So therefore, it will stick this 0 to here. And then the last one it picked up right here, it shift this one everything first before it stick this one in. So there you go. Because in the array of the string, it store this one as first position, second position, third position, and fourth position. But the real number is, this is first position, second position, third position, fourth position. And whenever you process the data, you will always enter at this spot. Okay? So therefore, you have to shift whatever you already have before you insert your new information in. So that's what it does. You see, there are lots of just a simple, one would think, hey, and there's lots of detailed work just to handle it. Okay? You got it now? So that's what it means here. So there's lots of things in here. Basically, shifting everything to the left one spot, filter out the newest data you have, add them together. Okay? Just because the way you type it in, human being type it in, high bit first, lower bit after, and the real number on the PC is what? Higher bit to the left, lower bit to the right. So that's how you process it in. Okay?
But if we wrote this in a language that read left or right.
Yeah. But the thing is, when you type it in, well, by default, we are writing from the left to the right, English. And then you hit the keyboard. But the thing is, no matter what, the keyboard enter determine the end of something, right? Even if somehow, let's say you're in another country where actually when you type something, it stops writing out from the right of the black line here, and they're coming that way. Still, you have to process something like this because it key on your keyboard or key on whatever you see in advance. So no matter what, whatever fed into your buffer, how the order in there, you need to handle it. And it just happened to be handled differently. Because what? We like to write from the left to the right, but anything on our right is a lower rank, a lower unit than it's on the left. Hey? That's how we got it. That's how we start our culture. That's how civilization. So what? Yeah. So somebody had to choose some way somewhere, and then you deal processes, you deal with tools to deal with that later. Okay. So that's what I have. If something goes wrong when it's going through the loop, that means you got funny character different than 0 or 1, boom. It give an error, say, hey, invalid error, even it tell you what digit even. Okay? So if you want to, we can go back here and play T and B, and let's say I go 0, 1, and then suddenly I go A1. It tell you, boom, hey, you messed up, guy. Okay. All right? So that's what it does. So that's the code if you happen to enter B. And then now I think you can handle that on your own because later it'll say, hey, if I found that it was 0 and X, or 0 and small x and x because you can do that. Hey, I know you are dealing with a hexadecimal. So I pick up my length again, I zero out my data, and because it's 16-bit, it better be less than 6. And then it start parsing. Hey, did you enter regular character 0 through 9? If it is, I know that you're dealing with 0 through 9. If I happen to see that you are putting A bigger than A or less than F, and that's the magic programming. It means you can put anything A, B, C, D, E, F, and this if will handle it. That's nice, isn't it? And then basically it's just shifting. Except because hexadecimal means it's 4-bit at a time. That's called nibble. That's why you see it shifting 4 at a time instead of shifting 1 at a time, as in case of a binary. Where did we go? Yeah, up here. But that's what it does. So you can see that, let's say you are entering, let's say you, for your case, you probably just say, oh, I'm going to stick with decimal because 1 mean, if I enter 1 mean it's call 1. And then 2 or 3 something may mean for the left, right, center or something. It's up to, you can see as you develop your code. Okay. And then, okay, so this one is handling hexadecimal. And then this thing here is when a decimal, and the decimal is nice because, hey, all you do is just push them in. Because if a decimal, you already got it made. You just take whatever the string is, 1, 2, 3, 4, send that one directly. Okay? And so that. So you have the code and you have the exe there. So you can just play with the exe and look at the code. You can see how it goes. But really, so it's up to you. It just is an example. Decimal, hex, or whatever. Your case, you're probably better off if you deal with decimal. And then for you, okay, which number correspond to which, how you prepare your bit. Actually, I think you're going to be better off using the binary so that you know which position, right? 16-bit position you already used to do that in task. Which bit is doing what? You do the same thing. So you use the code for the binary here, actually, and then prepare it, send it over.